Okay, so good morning, everybody. Thank you for being back here. Today is a very important day. We need to discuss and finally arrive to a consensus on our future work next year, which is a very important work for CoastPredict. And very briefly, just to say that we have a plenary this morning, which is only about 1 hour. And I don't know who is here. Yeah. There is something that requests. Okay, fine. So we have a plenary, and the plenary is about the presentation of yesterday's discussion and plus some important other presentations on key issues that methodological and technological components that we should keep in mind when we plan our global coast. And after that, we break out into 3 groups. Each group has a different link. I just, and I apologize if I forgot to do so, I just sent to the chairs and rapporteur of each group my presentation of yesterday, where there are some points. There will be a computer in each room. One room is this one, and the other 2 are down the hall. And so for the 3 breakout groups, you might want to check on how the number of people connected to your group, but we can also discuss this later. So we have the breakout group, and then we take a coffee break 11 o'clock, and we restart the working group, the breakout groups. And this afternoon we conclude by overviewing. So today, we start with a presentation of previous day discussion by Jay and Lorenzo. Please, have a seat. Now we have the screen here so you can see what you are presenting.
Good morning, everyone. Lorenzo Matowski and I will do the summary. Lorenzo was the rapporteur, took the notes, and so we'll share the presentation. This is basically setting a framework following up Nadia's discussion just a moment ago as to reflecting yesterday and reflecting today.
This is not a presentation, is
No,
it?
no, it is not. It isn't.
Okay, so this is not a presentation. The presentation, what is the title of your presentation they gave you? You gave it? Did you give a presentation or do you have a written?
No, it's just a speech.
Ah, okay. No presentation. Very nice. Okay. You should always put it on a slide, but it's fine.
Okay.
It's a code.
Okay. My fault. So, first of all, thanks a lot for the opportunity of being here and of participating to this very interesting meeting and the honor of being the rapporteur today. So first of all, something that was said yesterday very loud and clear is that clearly coastal resilience is a concept that goes beyond natural science. It is about, first of all, combining different types of science, so natural sciences, but also human science, such as economy, sociology, and so on. Yesterday, someone, I think Francesca Santoro, said something that I liked a lot. She said, she cited someone saying that the worst threat to the ocean is ignorance. I would extend this to coastal resilience. The worst threat to coastal resilience is ignorance. So coastal resilience goes beyond science. It is a coordination with policy making, with education, with making people aware of the risk, awareness and preparation, because sometimes things are unavoidable. And so there is this, it is not only cross-disciplinary, but also there is a collaboration between different institutions. Then another very interesting point that was made yesterday is that it is indeed difficult to collaborate between academics of different formation, for example, natural sciences versus economy or social sciences. Very often among academics this is only a problem of vocabulary, that people of different formation maybe indicate with the same word different concepts, or maybe have different words for the same concept. And so there is a real problem of understanding. So a real collaboration will go through a definition of a common vocabulary in the community that has to do with coastal resilience. And then it is also a matter of communicating with people outside of academy, from institutions, which still have another way of see the problem, they see the things from another angle. So it is still a problem of communicating between different institutions. And yesterday were mentioned also several examples where this have been done. And so we can take these as examples. And this was also my part, correct? Mm-hmm. Yes, okay. and it was also said that CoastPredict is the right place. It is clearly an initiative that has been conceived right to do this, to speak about coastal resilience. So not only about natural science, but really to put together all these pieces and know-how and angles to see in a different way the same problem, to put together experiences to tackle the problem of coastal resilience. And this will have to be done separately, keeping into account the experience and making a common cause to share all the experience. But for each focus area, clearly we'll have to consider the particular picture, socioeconomics, and from a point of view also of natural science, about that specific focus area, which will be clearly a bit different from what will happen, what characterizes other focus areas. And so this will be also an objective of this initiative, that of sharing a common ground, but at the same time knowing that each focus area has its own different needs and characteristics. Okay, so this part. Okay. So now another problem that was mentioned several times yesterday was the fact that CoastPredict is itself not a program that directly funds the projects. And so it was raised several times the way if there is a clear strategy. Because for each focus area, we'll need affiliated projects that indeed seek funding for that focus area. And this has been already done for some focus areas. There are already affiliated projects. But for new focus areas and new groups that want to participate, we need to define a common strategy to ask for funding for each focus area. And clearly we can somehow brand the projects with saying that it is part of CoastPredict, that is endorsed by UNESCO, that has the support of this community. And this is something that can help, this is something that was said yesterday, can help to find financial support to carry on the activity related to the developments in the focus area. And we have to discuss a bit the frame to create this strategy, a pathway to ask for funding in a, let's say, standardized way, quote unquote. And
Can I add some stuff?
yes, yes.
I think the question of funding is, as Lorenzo says, we each have to have the individual projects, but they will remain stovepipes unless the overall project is funded and has the management capability, the interface, the communication capabilities. And so the funding needs to be very broad, and we need to work through that together as a team. There was a lot of discussion on what is the project in terms of pilot sites and core sites. That took up most of the last session yesterday. And I don't think that was fully resolved. I think there were some concerns expressed to try and chew on something that's not an elephant, but maybe is manageable to eat. And so I think we have to decide that today in part. And of course, that's part of the discussions from the breakouts and elsewhere. The process of selection has to do with the idea of a family, of a community. In fact, we have to be a community together. But like I like to say, the bride's father needs to meet the groom. And that simply means that those pilots that join us will be part of our family. And we're going to have to work with them in that way, support them, but they're going to have to support us. And so as we begin to think about sites, let's keep the human factors. Let's keep the reality of the process of engagement in the forefront. There was a question of what's the minimum threshold of infrastructure that's necessary for a pilot site. Basically, what are the pilot site requirements? And in the breakout today, that's going to be a subject that we need to address, because ultimately we need selection criteria. Otherwise, when we go for funding, people won't understand our project. So let me summarize just with the comment that we have to be a community in helping each other, in working together, but that's a broad community, not just the people in this room. And so with that, I'd like to, I think, conclude the summary. Thank you, Lorenzo. Thank you, everybody.
Thank you, Lorenzo and Jay. I think that is, even if there are no slides, you were very clear, and I would say that we would like to get your notes, and that all the points that you've made have been discussed yesterday, in my opinion, and some of them more than others. But they are very relevant to construct the global coast experiment, and hopefully that will end into the funding of the overall that we can probably figure out in the next year, the year to come. So I'd like to open the floor for a few questions, not many, because I hope in the afternoon you will be in the breakout, you will be discussing more of this. Yes, please, Louis. 1 second.
So thank you very much. I think that the 2 days were very interesting. I have heard a lot of, and I have learned a lot about the approach that you are following for the CoastPredict. And yesterday, I just was talking with Joaquin about the things that they are missing in here. So you are connecting the hydrography and the dynamics of the ocean, or let me go back one step, the coastal waters, which include almost the shelf. Which the coastal waters, which include the shelf and even the slope, and the human dimension. But I think that we are missing here a lot of things. For example, and Joaquin also mentioned it, we have to consider that marine spatial planning covers a lot of many more things than the things that we have been discussing in here, including the geology, the tourism, the energy, many other things. including the biology. So we have to consider that when we are talking about resilience, we have to consider the restoration of ecosystems, we have to consider biodiversity and other issues related with the biology. And I have not heard a lot of things about biology during these 2 days. One of the key players that can help CoastPredict to fly and to is the OECD, and you mentioned it, the OECD yesterday. I think that the OECD, when they produce this very nice volume about blue economy, they have very good ideas there. During my life in Paris, the OECD was a key player that was always in our radar when we need to know something about the use of the ocean in terms of economy. And I think that they have good experts that should be part as well of the advisory board for this CoastPredict project. So those are some reflections about the discussion those 2 days, and well, I would like to share them with you. Okay.
Yeah, I think you've expressed something that's probably been on our minds, but we need to bring it to the forefront. And there's been discussion of, for example, Nadia having a focus area on biology and the biological ocean. And we haven't had that discussion yet, but you're raising it as the prominence of the full spectrum of ocean aspects. And so that we need to put that on the agenda. The other thing I'd like to comment is on stakeholder engagement. Yesterday we had 3 very nice presentations at the end of the day from Holger and Edgar, etc., on their engaging stakeholders and how that can be done effectively. We need to also think about that process, and we need to unify it among the various experiences so we have a way to approach the stakeholders, and the stakeholders in this case are the economists, are the local communities and the pilot sites, etc. So I would add that as a comment.
So in terms of advisory, general advisory, I think this is a gap, and we will try to fill it for OECD and seeing how they can contribute to our project or to the advisory of our project. In terms of biology, and we have it throughout the multidisciplinarity. It's not a question. The point is that there are no projects at the moment advancing this. And maybe what we should do is in the future get more projects that would look in particular to that aspect. And the fact that we organize ourselves in a global coast experiment is because we want to concentrate a multidisciplinary approach in one place and focus the many technologies that we know and the many sciences that are compose the support of coastal resilience, the natural sciences, for example, and we try to focus it in one area, because doing it all over, you normally cut the multidisciplinarity. So even if you're only biological, you're not interdisciplinary because you're biological. So, and then I conclude, you may be in each area, you might have more biology than physics, but that depends on the challenge of the area. So it depends what is that area is significant for. And definitely then we will concentrate on that topic. Yes, Louis, yes, I'll reply, and then Willy.
Yeah, I recognize the difficulty of bringing people from biologists to this kind of big programs, but I think that there are some elements already going on in the arena. For example, in the IOC, we have the Harmful Algal Blooms program, which is very well established since 30 years ago. And they are always searching for programs like this where they can just collaborate and put the science they are doing with you. Also, the people working in upwelling systems, and when you showed yesterday the 20 areas in the world ocean that you want to work with, you mentioned the eastern boundary currents. That means the upwelling in the Sahara, in Namibia, in Peru, Chile, and so on. I think that these people also can be attracted by this kind of programs. And another one, which is very important to me, this is the invasive species. The invasive species is a really global problem, and this is something very much related with coastal resilience in terms of biodiversity. And in fact, in the Mediterranean is one of the regional seas where you have more invasive species. I think that the people working in invasive species can be also very interested in this kind of approach that you are presenting in here. So those are groups that are very well established, like the harmful algal bloom programs, others that in the mid-way in terms of establishment, and others that are starting, like the invasive species, but you can approach them. The ocean decade is just starting. It has started 2 years ago. So you still have time just to build up this kind of approach for coastal resilience and for CoastPredict. One more thing. Alison yesterday from Paris, she mentioned that there is going to be a big conference in Barcelona in April 2024. I will be one of the main organizers, and Joaquin is with me, working with me in the National Decade Committee in Spain. So if you need something, just approach me or Joaquin and Joaquin to me, and I will do my best just to favor the presence of CoastPredict in that conference.
Yes, quickly along the lines of the last comments by Luis, I totally agree that we have to do this through collaborations. You're both right. CoastPredict has not put an emphasis so far on the biology, but it is definitely a part where CoastPredict, which is embraced by CoastPredict. But I think we have to capitalize on actions, activities, and programs that are already in place. And I want to bring up Marine Life 2030 as they're building their projects. And from the beginning, as we were talking to them, we can really collaborate on some of their coastal focus. And more than that, I think that CoastPredict should select activities where CoastPredict can bring something more. For instance, I'll give the example of connectivity. For instance, sargassum in the Caribbean, right? The physics and CoastPredict predictions and observations can bring the part that connects the pieces, because a lot of times biology works very locally. So we have to really be very selective and do something where CoastPredict can make some transformation.
Very quick comment to Luis. Thanks very much, Luis. I think to us, your international experience is, as you know, and we've been together many times, but your international experience is precious to CoastPredict, and everything. Having you here is very, very important for us. As you know, CoastPredict somehow follows a multidisciplinary problem-solving approach, somehow following what NOAA Department of Conservation, Restorations, Response, Solutions. And on these, definitely the biodiversity and ecosystem part is essential. Just to tell you some of the activities that we have been trying, but we have not been, in the same sense that we don't have answers to all the questions. We are not succeeding in all our initiatives, let me be very clear. And for example, in this area, in Focus Area 4, for example, we have been in contact with different people, but the fact that there's no direct funding behind makes things difficult. And for example, we have been discussing quite in different meetings with Angel Borja or other teams that are very strongly involved in exactly what you're saying and related to the European directive, etc. But they are extremely busy. So they are supportive, they are enthusiastic, they are everything, but they have not been able to lead one of the projects in Focus Area 4 like we were trying. But the floor is open, and definitely through the teams that you coordinate also at EAO or others, for FA4 and the others, definitely the need for new projects is there, certainly. Thanks.
Yeah, thank you, Joachim, for reminding us that, in fact, we need your input for Focus Area 4, which we had starting co-leads, but they asked us to be in the group but not lead the group because of their work. And we need really your help, Louis, if you can give us help. We really want to strengthen that component, and hopefully we will. And I particularly like your mentioning of hubs, because this has been in my agenda for now 2 years, actually, to contact. We just postponed because we invited, for example, Marine Spatial Planning of UNESCO IOC, because we know that we need to in-train their experience, and you had the presentation yesterday, but certainly hubs is there. We have many, we have been searching for the right connection, and we will, especially in Focus Area 4, it should be the main aim. So, what Jay was saying, the biology kind of more dominated focus area is 4, and we will. I mean, especially if your help and other people help, will find a good leadership that will drive a core project, and so it's important. Okay, so so thank you very much. Jay, Lorenzo, it was very interesting and a very nice overview. And this will serve the breakout groups too. Yeah. Okay, so we then start with these 3 presentations in the morning before the breakout. And let me check if Taco or Lucy are available.
Definitely.
Hi, good morning, Taco.
Good morning. Good morning to
Good
you
man.
all.
Yes. So how do we go? Do you want to share yourself, your presentation? Let's try. Is it possible?
Yes, please.
Yeah, we see you. We see you. Thank you. You can start, please.
Thank you. And thank you for the opportunity. I just have to do something here because so, thank you very much for this opportunity to inform you about the Ocean Info Hub project and the ODIS architecture. I'm presenting on behalf of Lucy Scott, who is the Ocean Info Hub project manager. Now, Ocean Info Hub and its underlying ODIS architecture is about sharing of data and information. Ocean Info Hub is a global initiative that aims to improve equitable access to ocean information, data, metadata, and knowledge products. And it's built on the Ocean Data and Information System architecture. And the development is fully based on co-design. It's a 4-year project, and we still have 1.5 years to do wonderful things. It's actually 3 very closely related initiatives: Ocean Info Hub, ODIS CAT, and the ODIS architecture. The ODIS Catalog of Sources, or short ODIS CAT, is an annotated catalog of online resources serving ocean-related data and information products, currently containing over 3,000 records. The Ocean Data Information, ODIS, architecture is the underlying architecture of Ocean Info Hub, And Ocean Info Hub itself has developed the first phase of the ODIS architecture and is concerned with involving user communities and establishing proof of concept of ODIS. Now, it's very important to realize that Ocean Info Hub is not another new system, but it is connecting existing and future data and information systems in a sustainable, interoperable, inclusive, and openly accessible way. It is composed of nodes and thus forms a kind of digital ecosystem, and it does not depend on a central hub. The web itself is our collective hub. It's also important to notice that partners have complete ownership and control and choose which data and metadata and information they would like to share. Anyone can develop their own thematic or regional portals using the Ocean Info Hub approach, and partners can pull data from the system or push data to the system or do both. The architecture itself is a lightweight, minimal layer and designed so that the existing workflows should not need to change. The ODIS architecture links the node through a schema.org based decentralized interoperability architecture. This digital ecosystem is, as with natural ecosystems, resilient to the gain or loss of parts and accommodate a high diversity of products and services while maintaining its core functions. This means that even if nodes disappear or appear, the ecosystem, the digital ecosystem, will continue to work and operate as planned. We started with some 6 priority themes to test this proof of concept. And these 6 were, you can see the list here to the left, and these 6 were chosen from the data categories in ODIS CAT. And now to what has Ocean Info Hub already achieved? Well, first, it has some very active technical working groups, and the proof of concept was achieved. So the first conclusion is it works. We're currently sharing over 500,000 content items. Of course, all the information, the documentation on the ODIS architecture is freely available. It's open source. And IOC partners and 3 regional communities are implementing 1 or more of the patterns. The Ocean Info Hub links global IOC and UNESCO databases such as Ocean Expert, Aqueducts, the Ocean Best Practices System, and data from the Ocean Biodiversity Information System, and soon to be the from data from the World Ocean Database. Again, important to notice that this is a mix of data, classical data types, and information types, and a big diversity of information types, and they're all linked together and can be searched this way. The pilot regions, there are 3 pilot regions defined, and here you can see on these little maps that there is a pilot region for Latin America and the Caribbean, for Africa, and for the Pacific small island developing states. But it's not all. There are some 47 implementation partners, and to the right of this graph, you can see that the partners in green, they have already, the data and or information from these partners has already been indexed in the Ocean Info Hub graph, while the partners in white, their development, the cooperation is ongoing work, and they will soon be added to the Ocean Info Hub graph. Also, Ocean Info Hub has its impacts on international frameworks. For instance, Ocean InfoHub assists countries in their reporting requirements for the Sustainable Development Goals. It contributes to the Paris Agreement, to the Sendai Framework for Disaster Risk Reduction, and to marine biological diversity of areas beyond national jurisdiction. The most important one to mention here is that it contributes to key aims of the UN Decade of Ocean Science, and Ocean InfoHub is leading the Ocean Data 2030 program, an endorsed program of the UN Ocean Decade, and thus it is, and this way it is easier to work together with other endorsed programs such as CoastPredict. The benefits of the Ocean InfoHub approach with this underlying ODIS architecture is that for data providers, they have to share their data, metadata, information only once, while fully retaining ownership and control, can change visibility of their data as they choose and increase the visibility of the data. The data user, on the other hand, will find it much more easy to find and access data and information, can easily see which are trusted sources and access the same data set through the portal or resource best suited to them. This way, this digital ecosystem can be entered on any portal or resource of choice. And existing global and regional portals can access the ODIS knowledge graph, reshare those of regional, those data and information parts of regional and thematic interest, and every record always links to the original source. And again, one can be a contributor as well as a user. So in summary, the data, well, already said, is data information owners retain complete control of their data. Ocean InfoHub always links back to the original authoritative source. Anyone can access the records in the knowledge graph for their own portal, and anyone can link in and contribute records. And then please use our resources and share your feedback so that we can further improve the resources. I assume that this presentation will be made available through all participants to this conference. And so here are some links to the resources that I just mentioned. And my final slide is a call to all of you to join Ocean InfoHub and build a truly shared ocean. Thank you very much.
Thank you very much, Taco. We don't have really time for discussion. Very informative, I think. CoastPredict, I think I can say, even if we haven't discussed it fully, wants to contribute to InfoHub and more. If there is one question from the audience, okay. If not, I think we are a bit late. We started a bit late. Thank you again for being with us, and please stay with us if you can. And then we proceed with, yes, a presentation of Coastal Relocatable Observing System and Community Science. You can come here, yes. And you can use actually, because now you can look directly. Great. Please. Sit down. Yeah. And Laurent Delaunay from IFREMER. We're talking about Coastal Relocatable Observing Systems and Community Science. Again, this is an existing experience, and we should take advantage.
Okay, you should hear me. So I'm going to look at the time to try to be sharp. So yes, I'm Laurent Delaunay, and I am coordinating the Joint European Research Infrastructures for Coastal Regions. And then I'm going to make a very fast presentation of Jericho, and then I will switch on the coastal relocatable observing system that I want to present you. So Jericho is, as I said, the Joint European Research Infrastructure for Coastal Observatories. We have a vision is that to become by 2030 the European gateway to long-term scientific observations and related services for European coastal marine systems. And the mission is quite complex, but I'm going to focus on very important keywords. This European coastal observing system is a multidisciplinary system, and it engages some multi-platform observing systems, and the objective is to obtain a holistic appraisal of the coastal marine system change. And of course, we are engaged in very key objectives like to enable open access to state-of-the-art and innovative facilities, resources, fair data, and fit-for-purpose servicing, fostering international science collaborations. And I would like to end this introduction by why Jericho is unique. It's because it's multidisciplinary, multi-platforms, and it has a holistic appraisal of the coastal marine system. The potential of such a European coastal system, it is physical integrations, virtual integrations, and a geopolitical integration as well. We are addressing some key science objectives, and all the objectives that are indicated on the right are structured in three key scientific challenges. The first one is to assess and predict the change of coastal marine systems under the combined influence of global and local drivers. The second one is to assess the impact of extreme events on those changes. And the third one is on revealing the impact of natural and anthropogenic drivers of climate change. So Jericho, as you can see in the green area, is in a strategic position within the research infrastructure European landscape, because the coastal domain, as you may all know here, is at the interface between land and oceans. Jericho area, it's a connection of national network that does already exist in Europe. As you can see on this map, the country with the red star are offering an already established national coastal observation national networks. So it engaged in the international expertise for an integrated multidisciplinary approach. We are the partnership is based on 19 nations. And more than 40 partners. And of course, Jericho is the sum of the national roadmaps. This Jericho network is based on more than 500 platforms, is structured in 13 European regions, and as I already said, it engaged 19 nations and more than 40 partners. We are addressing many key variables that are of prime importance for the coastal science. I'm not going to mention all of them, but there are about 4 categories: physical oceanography, marine biogeochemistry, biological oceanography, and other variables. Yes, I spoke about the structuration of this coastal observation system. It's based on 13 Jericho strategic regions, are all mentioned in the right, and in these regions, we are using many observing platforms like bottom-based observatory, fixed platforms, high-frequency radar, manual sampling. We should not forget that. We are not only addressing automatic observing system, but manual sampling as well. And it's based, the observing platform are based on ferry box, gliders, profiler, research vessels, surface drifters. Jericho is trying to perform an alignment of strategies for collaboration at the regional level, EU level, and as well between the various research infrastructures that are engaged in the marine domain. And the objective is to engage a synergy, to coordinate, optimize, generate added value. So Jericho started in 2005, and then the first funded project started from 2011 up to 2015. It was the objective was to set up the state-of-the-art of the coastal observation infrastructures and network in Europe. It was mainly dedicated to physical data, and then a second funded project called Jericho Next happened. We introduced additional observing system like high-frequency radars, and we worked a lot on development of sensors dedicated to biology. And there are actually 2 running projects, Jericho S3 and Jericho DS. Yeah, and Jericho DS, the first one, Jericho S3, is mainly dedicated to make a good structuration at the regional level of this network, and Jericho Design Study is more dedicated to engage the nation in Europe in order to build up the future Jericho research infrastructures via an S3 applications to become in the future an ERIC. So we are talking about services for this network, and the services are like transnational access with fixed platform, gliders, ferrybox, multi-platforms possibilities, and other special equipments. And of course, we offer some virtual access with the Jericho core that was presented yesterday by Miguel, and that is part of the initiative in CoastPredict. And of course, we offer as well some services with calibration facility dedicated to coastal observations. The whole data chain is monitored by Jericho. And a few words about the Jericho core, that is the unified central hub of Jericho area in order to discover, access, manage, and interact with Jericho area resources. The vision of Jericho core is to have a coastal ocean resource environment of the Jericho research infrastructures, and as well to enhance virtual access to all Jericho-related resources. The mission is to improve coastal data and information fairness by facilitating the development of services to support specialized thematic and research activities, but as well to build synergy for coastal ocean resource and services between Jericho area and other international research infrastructures. The Jericho area resources, specific data sets, software, best practices, manual publication project, etc. The Jericho area site, I already mentioned them, and the purpose is to develop, at the moment, multi-platform data integration for future projects. Let's talk about coastal relocatable observing systems. The first one I'm going to talk about was a development that was made during Jericho Next. It's a low-cost system, the Mastodon system. It's based on an electronic system, a flotation system, and it's a very low-cost system, and it allows to do some water column, water temperature measurements in order mainly to address internal wave assessment. And up to right now, there is an upgrade version of this low-cost Mastodon system that on board now you can have temperature pressure on a profiling line, and as well at the bottom, oxygen and turbidity. So it's quite a low-cost system. It's very easy to deploy. You deploy it for 1 month, 2 months, 3 months, and it records the data. And at the end, when you recover the system, you can have some kind of graph as it's presented on the left in order to address the internal waves. Let's talk very few words about other relocatable systems that are now on the market from many manufacturers. These are some very, very easily deployed autonomous underwater vehicle on which you can set up some simple payload in order to address, for example, CTD or doing some bottom observations, and as well oxygen measurements and so on. And the advantage of the system is that it's very small, it can be deployed very easily, and the price is not low-cost system, but still it's very cheap in comparison with bigger and more deployment difficult. Yeah. So when we talk about low-cost system, I mean, we must not only think about small sensors that cost 20 euros and that are spread in many parts of the area you want to address, but as well, there are still some very high technology systems, but more simple, easy to deploy, and still more affordable. So the last coastal relocatable systems I would like to talk about is a demonstration that we performed in the Jericho project that are running right now in Jericho S3. It's in order to demonstrate the possibility to have generic instrument modules dedicated to integrated observations. Jericho S3 decided to use an already developed systems dedicated to seafloor observation in the deep sea, thanks to EMSO research infrastructures that transferred their technology to Jericho, and we made a less expensive coastal module up to the thing that the coastal constraint in terms of depth, so in terms of mechanical resistance, it's much less than in deep sea. So we managed to reduce the cost of the whole structures. And this coastal AGIM is for under EMSO generic instrument module. The idea is to have a generic instrument modules for easy low-depth deployment that can host in-situ sensors and dynamically manage the sampling protocols. So it's meant that the dynamic sampling protocol management is made by embedded algorithms that are analyzing the in-situ real-time data and that can take some decisions in terms of triggering a specific sensors, making it speed up the sampling time, and trying to synchronize some specific sensors in order to address some specific scientific objectives. The Jericho S3 demonstration is focused on phytoplanktonic bloom analysis studies. And during the Jericho S3 project, we went through a full site analysis in order to choose the better sites to demonstrate the instruments, and we could help the global coastal experiment in our experience to involve these site selections. It's not a problem. So the student site is in the Seine estuary. It's close to already existing Mare Smile buoys. It will be deployed at 20 meters depth. The coastal regime will be in autonomous mode, no connection with the buoys, neither with the shore. The embedded algorithm will be run in situ up to the junction box that is part of the coastal regime. And this, up to now, the system was tested last December in a specific testing site close to Ifremer Institute in Brest, in France. And the proper Jericho S3 demonstration is planned in spring 2023. This module have CTD O2 oxygen fluorescence turbinometer. It has as well a fluoroprobe that is dedicated to chlorophyll and algal classifications. We have nitrate on board up to an isotlantic systems, and as well we managed to have a UVP6 that is an underwater vision profiler in order to have some in situ planktonic imaging. So this is the conclusion of this specific relocatable observing systems dedicated to the complex coastal observations. We have now a high capability and highly adaptable and relocatable coastal observing module with embedding algorithm on board, with an extensive sensors driver library. That means that we can host some other sensors available in the market. It's an asset for in situ monitoring complex coastal process study, and the next step in the future will be to implement some depth surfaced data link, surely with acoustic modems, and as well some data link to shore stations, for example, to monitor in situ the processes and act on the behaviors of sensors in real time. Thanks a lot.
Thank you very much, Laurent, and I'm really excited about to see so much progress. I haven't been visiting the Jericho in 4 or 5 years, and I see an explosion, so it's maybe the COVID helped.
What do you mean?
Meaning that
No, I mean,
engineers were working in the lab. So I think that these systems are really very important. So we have, CoastPredict also said, we have to use as much as possible new technologies in the coastal area. And these are relocatable, which is another principle. So we definitely have to work very closely with Jericho and try to, in some of our sites, have your contribution, even if they're not European. I hope we will try to do so. So please, I mean, another relocatability that we need to explore in CoastPredict is the relocatability of a low-cost system, which is also very important for the questions related to coastal resilience that makes awareness and participation of the local community to monitoring their piece of ocean, their piece of coast. So please, if we can keep it in the 5 minutes. Yes, thank you. Jay.
Okay, can we go to the next presentation on the community science, please? One of the things that was not mentioned by Laurent is that in addition to the sensors, we're looking at community science, and in particular citizen science is a word that we use as part of an information asset that can be used for the coastal environment. And I'm doing a presentation on behalf of Patrick Guringe and Lucy Kokempo in how to move forward in the CoastPredict area for citizen science. And we saw yesterday one from Australia where they were looking at the coast, which was really exciting. I want to focus this presentation, or I should say Patrick wanted to focus it, can we go to the next slide please, on how do we engage as we have multiple pilots globally?
Yeah.
Oh, thank you very much. Magic tools. And what we're facing in terms of motivation or the need for a global perspective of the ocean in addressing the major issues such as climate and sustainability. And to understand that we need interoperable methods across our various pilot sites. And yet those people at the different pilot sites have different capabilities and infrastructure. So we have to be able to adapt the methods that we want to the local environment. And this is a focus of the discussions that we've been having.
Yeah, great.
There you go. Okay. And so our strategy is to create a best practice adaptations that are usable in various regions, and that would address the interoperability challenge. And the work would leverage an initial pilot which was done by the Ocean Best Practices System. It was a task team focused from Ifremer and also South Africa, where we're looking at coastal South Africa and how we can do measurements just near shore that can be extending the very few buoys that exist around the coast of Africa. I'm not going to go through these for the shortness of time, but you'll have a complete version of the directions we're going. I did want to comment that this activity is related to low-cost solutions. Let me emphasize that. Capacity building, citizen science, and works or focuses on the EOVs, and this was a discussion with Emma and the GOOS engagement in this activity. And we're going end to end in the value chain from sensor development all the way through data and information. The last slide I have, and I do apologize for going so quickly, is building this out as a community of interest. We have the core, which was the task team that's run by South Africa and France. But as we were going through the Ocean Best Practice System workshop about 2 months ago in September, 3 months ago, there were suggestions that really we ought to have this as a broader activity, including South America, the South Pacific, and other groups. And so we've had a request now to expand the demonstration project to multiple areas across the globe. And we're going to be submitting a decade project proposal in this area to CoastPredict and to Ocean Best Practice Systems for a collaboration. They'd like to stop there, but I do want to invite those interested in this, particularly for different regions of the globe, to join us in this activity, and you can talk to me about it, and we'd be happy to work with you. Thank you very much.
Thank you, Jay. If people have been just for people who did not get in touch with us, we have been trying to sponsor the growth of projects like this one in community science for a long time now. And, you know, really this is a great effort, Jay, that you undertake. And I think that it will be even more coming, you know, more things that will come in the future to contribute. And we don't have time for questions now. Thank you very much, Laurent. And but in the breakout, yes. And so please, and then I ask the last presentation for today on relocatable modeling systems by Annabella Oliveira from the laboratory of the National Laboratory of Environmental Engineering. Let me say it this way. It's very difficult. And it's from Portugal. She is one of our strong supporter, and this is a real nice example of what technology CoastPredict can deploy in an area, and you know, for predict on time, but more even. Thank you. Please come.
Good morning, everyone. I'd like to start by thanking the nice invitation that was given by CoastPredict for me to be here and talk with you about relocatable forecast systems. First, I'd like to acknowledge my co-author, Francesco Trotta, from CMCC, representing here the SURF community. And by the way, I am a researcher at the National Laboratory for Civil Engineering in the Hydraulics and Environmental Department.
There it is, the good one.
Okay, so a brief outline of my talk. I will start by framing the work and the research that we do in the scope of coastal community needs, and look at coastal digital twins as the integrated solution to address these needs. Then I'll talk a little bit about the forecast systems, going over the definitions, and show you why we need not just forecast systems, but relocatable modeling and forecast systems to address these needs. I'll then briefly review two of the major efforts in this area, the open coasts and the SURF tools, and finalize with some considerations for what we have to do in this area for the future. So coastal communities have a lot of needs in order to address many of the challenges they face today, and these needs come from the environmental areas, economy, and social needs. And here I've summarized some of the challenges that they face. In the civil protection, the focus, we have the need to anticipate hazardous events and to support emergency actions in order to protect not only the people, but also the assets and the future of the coasts. We need to support the daily economy tasks, and these economy tasks are not only from the end users and the stakeholders, but also from the public in general, looking at leisure and recreation as important parts of our coastal uses. Finally, we also need to guide management in order for decisions to be taken in an integrated way, and also to avoid conflicting of uses in coastal areas, which unfortunately are quite common. So to address all of these problems, the notion of coastal digital twins as tools to be centered at the user needs, to provide on-demand frameworks and services for decentralized ocean-to-coast knowledge creation. And they involve the modeling tools, the forecasting tools, data collection, analysis, and processing, and also, most important of all, servicing provisioning, because if we have the tools and we cannot make them available for the people that are in the field taking decisions, then we fail in our jobs. So very briefly, you all know what forecasting is, the possibility to predict short-term coastal dynamics, and it involves the availability of forcings, so we can force our domain with the prediction from larger scales, from the ocean, and from land uses, either being from cities or from the hydrographic basins. It is typically based on process-based modeling, although that paradigm is changing towards artificial intelligence tools. Very importantly, it requires continuous validation of real-time data. I always say that I don't trust a forecast system that has no real-time data for a continuous validation. And we have a very particular experience where we had a coastal breach in a lagoon. We had a forecast system there. The moment the lagoon bar breached, then all of our forecast system was wrong because it didn't represent the proper dynamics. And one thing that people don't know about forecast systems is as we operate them over time, they become a very important long-term database of information for that system. Now, the less interesting part, it requires continuous and considerable computer resources for us to have reliable daily predictions. It requires the use of accurate and reliable tools. And typically, at least in the past, it was implemented on a site-specific way. So we had one forecast system for the Tagus estuary, another forecast system for the estuary X. And every time we deployed a specific system, it was based on a computer setting. And it makes it very difficult for us to keep it updated. So forecast systems are very good for us to be able to anticipate coastal dynamics, and they are evolved enough to be able to go from circulation, sediment dynamics, water quality, and biogeochemistry. And there are a lot of examples throughout the world of forecast systems that include all of these components. They provide very high resolutions in space and time, and since they are numerical tools, virtual tools, they are very good for us to test what-if scenarios, different configurations, building a new breakwater, a new pier, a new bridge over an estuary, and look at climate change impact assessment. And by doing this, we are able to build our knowledge on coastal dynamics by merging models and data. However, coastal forecast systems are complex to maintain from an IT perspective. It requires a lot of human resources that need to be available every day. And making upgrades on these systems, if they are side by side implemented, it is very difficult and very time consuming. So we at LNEC and several other people throughout the world have started developing the concept of on-demand forecasting. Forecasting as a system, so we built forecasting frameworks that can be then customized for each specific site. Every time I need to upgrade the model version, every time I want to upgrade with a new model, we can upgrade all of the forecast systems at the same time. So this way we make things updated with good quality and much lighter to maintain from IT point of view. And more importantly, we make this available for users to build their forecast systems by using these frameworks. So we decentralize the forecast system building and make it available for everyone. Now I'm going to talk very briefly about two of the major efforts that have been working in this area. The first one is OpenCoast. It has been developed by LNEC with the help of Lyon in France, Professor Xavier Bertin, and also Professor Sonia Castañedo from the University of Santander in Spain. Then we have the second system, SURF, which is developed by CMCC and the University of Bologna. And now I'm going to give some very brief description of each of them. First with OpenCoast. OpenCoast is a web portal to assemble forecast systems in the coastal regions selected by the user. So the users just have to interact with a web interface to be able to build a deployment, to manage their set of deployments, and also to visualize and download the results. It is both open access for the use, and it is based on open software. We also have a dissemination page with all the information that we provide on the system, manual, training material, etc. Then SURF That stands for Structured Relocatable Modeling and Forecasting Platform. It involves the nesting of NEMO and SciFem for doing a nesting of models for the large circulation from down to the coast. It's distributed as a virtual research environment where both the hydrodynamic and the pre- and post-processing tools are configured through a configuration file, making it very easy and very fast to develop a forecast system. Also, it is open access, and also it is open software. And these properties, in my point of view, are very important for this to be able to be used across the globe. Finally, it also has a dissemination webpage with manual training and the publications. So a bit of details on OpenCoast. So we have an interface, a web interface that you can use everywhere to build a forecast system through several very simple 7 to 8 steps, depending on whether you want to introduce water quality or not. It's very easy to configure the forcing that we use, doing 2D, 3D, with wave and current interaction, with or without water quality. And it's linked with, inside a flexible IT infrastructure that everyone can go, build on their own systems, and bring in new processes, new models, or new processing tools. As these require a lot of computational effort, we have been linking with the European Open Science Cloud infrastructure for the computational resources to do the runs and store the results. So the user doesn't need to have anything, just need to build a new forecast system. And in the figure, you can see an example of the configuration assistant and also of the outputs file. Okay, so an important thing here, besides the variable that we are predicting, we are using a lot of external providers to get the forcings for our simulation. So for the atmosphere, we use NOAA's inputs, Meteo France and Meteo Galicia. For the ocean, we have FAIR 2014 and CMEMS, both at global and the IB scale. And for the rivers, which is a very important part of the effort, as we are looking not only as outside the tidal inlets, but also inside the estuaries, we have the possibility to force with climatology and also for the user to link a river forecast system through an URL. As data comparison, we have 2 possibilities, an automatic comparison with data from a ModNet, and this is offered to the user in an automatic way. You see the grid, and you see all the ModNet stations that are inside that domain. And we also use process Sentinel-2 images for inundation predictions using an external service, the Warsica Remote Sensing Service, also open source. Now for the SURF platform, SURF allows for the nesting or the multiple nesting of several domains to go from the deep ocean down to coastal scale. It uses NEMO, a finite difference model, and SciFem to do all of this nesting, and it can be easily deployed through a configuration assistant to take into account all of these processes. And the user has full flexibility to do that. It has also been implemented in a number of places, as you can see in the map on the top. Finally, a little bit more details on SURF. SURF is composed by a number of components. Each of these components are configured through a configuration file, and then each of the components has a separate log file, so it makes it very easy if something goes wrong for the user to understand what the problem was. SURF also includes a number of pre- and processing tools, including a grid generation part, and a number of processing tools that allow the user to compare with the field data and to look at the results in a mapped way, as you can see in the figure. Finally, some ideas for the way ahead. We believe that relocatable forecast systems are very important components of our aim to build coastal digital twins that the user can use to interact directly and build knowledge and take good decisions. We believe that the tools that we are developing and other people around the world can offer reliable, flexible, and accurate services for a range of users at multiple scales, from the ocean scales down to the small spatial scales. And by small, I mean going down to a few meters resolution. If we want to simulate, for instance, the outflow of a wastewater network, we need to go down to a few meters resolution because the dynamics in the tidal estuary can be very fine. And going to larger scale, scales would mean to have a completely wrong prediction. So the plume would go one way, while in reality it would go the opposite way. The good news is that what we have so far is a good starting point, but there is much more work to be done, and we are more than willing to tailor it, to develop to the needs that the communities have for this type of purposes. Finally, I'm very happy to say that this has been two separated efforts, development effort and application efforts, and now we are starting to collaborate towards building a community relocatable forecast platform that can support not only coastal digital twins, but other needs of the coastal communities. And that's all. Thank you.
So thank you again for a very interesting presentation. Again, it is one of the concepts of CoastPredict, the global coastal ocean with similar, different tools intercompared in different areas. And so as well as observing, we need to have the modeling technology following. I don't have time to questions, but I'm sure you will have from the floor. Thank you again, Annabella. Okay, so we are half an hour late, but we should start a breakout group. So you organize yourself, and then we take the coffee break. And so I started to say that there are 3 rooms. One is this one. So group 1 is in this room. Group 2 and 3 are in the following there. And group 1 is Jason and Aletta, and you will take this place. Group 2 is Pierre de May and Tom Perry on second room from here. And then the third one is farther down, is Samantha and Annabella. And I hope you can divide yourself in the groups. We'll all discuss the same points. And we break at about 11 again. So thank you.